Okay, good day to all of you. So in this video tutorial, you're going to learn what is the function of analog write, how is it different with digital write, and then as you can see now, I'll be starting to code the Arduino sketch, not the usual setting up first the electronic components and then proceed with coding in the Arduino IDE. Actually, to show the functionality of analog write, I'm going to use a single LED. So if I'm going to use a single LED and we've already made a project which makes the LED blink, so can we use that same setup? Actually, in Arduino, we can. We can still reuse the same setup for a different Arduino sketch as long as the components needed for Arduino sketch are the same. So you don't need to, again, reconfigure or connect all the cables. No, if they do have the same wires, the same resistor, the same LED as for our example for today, so we can reuse again the setup and we don't need to set it up again. So let's start with our demonstration of how analog write works. So as a good programming practice, so we need to name our pin number to make it more descriptive. So number sign define, LED underscore 1, and then we have pin number 11. So again, so for this component to be recognized, we need to declare it in pin mode. Declare also its function or nature. Will it be an input or output? So again, pin mode in camel case, and then the name of the component or variable associated with the component. And since again, LED is an output electronic component, so of course, you must properly assign it as output. Since we've already finished with assigning the functionality of LED1 as an output, so we are going to declare other variables needed for the analog write. So we have int val is equal to 0. Okay, and then another variable int change is equal to 5. So this val has an initial value of 0 every time the Arduino sketch will be executed and also change. We always have a value of 5 at the start of the Arduino sketch. So we've already declared variables. Actually, these two variables are very important later on because we'll be using it in the void loop to get the appropriate values to be used by analog write. Okay, so let's go with void loop. Okay, for the void loop, we have val plus equal sign. We have change. So, in the previous chapter, programming Arduino, the basics. So, what does this line mean? So, change is a value of 5, and then val has a value of 0. And then, plus minus means you're going to add the value of val and change, which is 0 plus 5. After that, its value will be stored in the integer val. So meaning 0 plus 5 is equals to 5. Then the new value of val will be 5. Okay, next is we have this if condition. So if we have val is greater than 250, okay, or val is less than 5, and then since it is an if condition, we need to have a left curly bracket, and of course it will produce the corresponding right curly bracket. So we have change times equal to -1. So what is this condition means? Actually, this condition, this will show how the analog write works. Okay. So, let's see. And then after that, after the if condition, we're going to encode the next line of code. We have analog write. Okay, for analog write, we have, of course, the LED underscore 1, and then val. Okay, let's remember again its counterpart in digital, which is the digital write. Digital write, as I have said in my previous tutorial, that it only has two values. We have high or low. For analog, so digital means it only accepts two values, 0 or 5 volts. For analog write, it can accept different values. Okay, the acceptable values for analog write is from 0 to 255. That is the recognized value for for its parameter here for the value. So what does this line do? Based on the values that will be derived from this if condition, um, the value that will be derived will be used by analog write, and that corresponding value in voltage will be used by analog write to make the LED brighter or dimmer. So it means that for digital write, which is only on and off for the LED, as you can remember, it blinking the LED. So analog write has a different effect. It will lessen the intensity of the brightness of an LED depending on the value that is stored in val. And then we will have a delay of, example is we have 100 milliseconds. So this is already complete. So let's check if we have any errors. Okay, let's save first. So since this is we have um, analog, okay, what can we describe? It displays different intensities of the brightness of the LED. So we have, you can do differing brightness LED. You can just to describe what will this code or the Arduino sketch will do. So let's save and then wait for it to be verified if we have any errors. So it does not have any errors. So we are ready to upload this in the Arduino board. So next is we're going to upload it now.
Okay, so we are ready now to upload our Arduino sketch in our Arduino board. So again, as you can see, this is also the setup that I've used in blinking the LED. So that's why it's very advantageous that you don't need to reconfigure, to reconnect all the wires, the electronic components for different Arduino sketch, as long as their electronic component setup requirements are just the same. So, okay, so again, I've already properly configured our Arduino board to the computer, and I've already connected it to the USB port. So let's upload it. So let's see the difference between digital write, which is for blinking the LED. It makes the LED blink on and off indefinitely depending on the time that you have assigned in the delay function. So let's upload. Let's not wait any longer. So wait for it to upload. Okay, so as you can see, okay, since based on our Arduino sketch, the change is -1. So it's a little slow. But you can already see that it is gradually, from being the brightest, it will gradually lose its brightness, and then it will be zero brightness or off, and then it will again return to the state where brightness, and then it goes on and on with the it's not just on and off, but as you can see that it gradually um, goes off, and then it will gradually turns on again. So it's not just, for example, it's not just on and off. It's not just, for example, in our real world, hot and cold. So for hot and cold water, we have lukewarm, or there's a value for that. That is the purpose of analog right. It's like, for example, an LED, we have dimmest, dimmer, dim, then bright, brighter, brightest. It has a corresponding value. So that's the function of analog write. It only not displays two values, unlike digital write, which is high and low. Analog write displays different values and converts it to the corresponding voltage. So have this one. It's a little bit slow, though it is already in 100 milliseconds. So again, we can play with the values of our Arduino sketch, such as make this the reaction of the LED faster. So instead of 100 milliseconds, let's try 10, and then again upload it. Okay, it's already uploaded. So you can see, because I adjusted the delay into 10 milliseconds, so the effect is faster. It's like pulsing. It's not blinking. Okay, that is typically for digital, right? So for analog, you see, it's pulsing. So what changes can we still do here? Example, for the if, we have the values of 250, and then we have 5. Since analog write accepts values from 0 to 255, let's try it, make it maximum and minimum. We have 255 and then 0. Then let's see what's the effect. Okay, so you can see, if I max out the value from 250 to 255, and then we have from 5 then to 0, as you can see, the pulsating is not that smooth, because you've already are on the maximum and the minimum. So that's why in our original code, it's only 250 and 5. The smallest value is 5, and then the highest value is 250. What if again you want to change it into the higher value? Since 255, make it 300, and then make it -5. What will be the effect? So that we can see what will be the effect if we put these values in the if condition. So let's upload it again. So what happens? So it's like it's flickering. Okay, I've set the highest value to 300, which is actually out of bounds for the analog, which is 0 to 255. And then the smallest value is -5. As you can see, it is flickering. So actually, you can change the value. So again, let's make it again to 5 for the smallest value. Okay, let's make it, for example, make the range shorter. So the original is 250. So let's make it into 100, the highest value. So let's see again. Okay, you can see the pulsating is faster because the range of values is shorter. Though you already also the delay function makes it faster for pulsating. Okay, let's return this again to the original 250. So let's upload it again. Okay, so you can see the brightness has more range compared if the highest value is 100, and then this is the 250. So let's change the value of change. Example is we have -1. Okay, let's make it -5. Let's see what is the effect on the LED. So the effect, okay, it's flickering. flickering like a candle. So you can say so like that. Actually, if you can imagine, LED candles are already popular. So it looks like this if our change is -5. And then what if, for example, you have to change it to -10? Let's see what's the effect of the value. So as you can see, it flickers on the start, but it's already steady. So that's the effect if our change is -10. So what if we're going to change it again? We have -1, that's the original. Make it 5, a positive value. So let's see if we have, if we can do this. Okay, just like the -5, it is also, this is also flickering. Okay, let's make it a 10. Let's see what will be the effect if we change the value of change variable to 10. Okay, actually, it's just to have the same effect with -10. It will flicker on the start, and then it will constantly, the intensity of the brightness of the LED does not change. So, okay, again, it's already demonstrated here that you can play the values of the in the if condition of the value, the range of the values, and also the change, and also the delay. So let's return to its original value. We have -1, and then for the change, and then for the delay is we have 100. Okay, so we return to our original code. So, so in this lesson, you've already seen that the different, what is the effect of analog write in an LED, or in any electronic components, as different with the digital write. And then I hope again you've learned something for this lesson of how to use analog write. So if you have any questions, so please free to comment below, and don't forget to subscribe to my channel. And then I hope that I'll see you in my other video tutorials. So again, thank you very much and good day.